Welcome to The Explainer. Today, we're jumping straight into the incredibly high-stakes, meticulously engineered world of ISO tank logistics. Just picture this. You're moving 25,000 liters of highly hazardous, molten chemicals all the way from Rotterdam to Shanghai. It's going to travel by truck, by ship, and by rail. And get this, without ever being transferred to another container. It's an incredible feat of global trade, and it's all made possible by the ISO tank. But here's the catch. Operating these engineered pressure vessels, it requires an absolutely airtight safety information chain. A single paperwork oversight, literally just putting your trust in the wrong document, can trigger massive supply chain disruptions, port closures, or worse, serious safety incidents. So today, we're exposing a very specific, very dangerous blind spot in chemical logistics. We call it the SDS Trap. So let's actually dive right into this. Picture a busy depot gate. A tank rolls up, and the surveyor standing there has exactly 30 seconds, maybe less, to evaluate this asset. Maybe the tank itself doesn't have any warning placards on it, right? But the documentation in the driver's hand clearly shows a dangerous previous cargo. Well, what happens in that tiny 30-second window? That surveyor has to make a split-second, absolutely critical choice. Does he trust the paperwork he's been handed, or does he trust the physical tank sitting right in front of him? This exact moment at the gate, this is where real dangerous goods awareness actually happens out in the field. And honestly, it highlights a massive vulnerability in our logistics chain. This heavy reliance on documentation without a shared operational understanding. Which brings us to what is probably the single most dangerous assumption a logistics planner can make. And I want to pose this critical question directly to you guys. Is the safety data sheet, the SDS, the ultimate law for transporting a chemical? Look, far too many professionals out there treat the transport process like it's just a simple data entry exercise. They grab the SDS from the chemical manufacturer, copy the handling instructions onto their transport plan, and boom, consider the job done. But let me tell you, framing your entire transport process like that, it's a high-stakes trap. Assuming the SDS is the ultimate final authority is exactly how catastrophic mistakes happen in international shipping. To really understand why it's a trap, we need to look at the first pillar of any solid transport plan: substance intel. Now, your first source of intelligence is indeed the safety data sheet, but you have to view the SDS for what it actually is. It's basically the cargo's chemical biography. It tells you the physical and chemical properties, the hazards, and, the generic recommendations provided by the shipper based on global harmonized systems. It's your very first clue in what is essentially a much larger investigation. So it gives you the background narrative, sure, but it is absolutely not the definitive legal ruling on how to actually move that hazardous cargo across international waters. If you want to build a bulletproof, fully compliant transport plan, expert planners know they can't just guess. They follow a very specific flow of intelligence. Step 1, of course, you receive the SDS. But step 2 is where it gets real. You bypass all that generic advice and immediately check Section 14. That's where the transport information lives. Step 3, you extract the specific UN number assigned to that chemical. And finally, step 4, you take that UN number and you use it to unlock the DGL, the Dangerous Goods List. You see the progression? You're logically navigating from the initial, generic paperwork straight into the strict international regulatory framework. Listen, I really cannot overstate this. The UN number is the key. The whole classification process for dangerous goods revolves around the allocation of this unique 4-digit number by the United Nations, along with a proper shipping name. Once you have that UN number, let's say UN 1993 for a flammable liquid, or UN 2810 for a toxic liquid, the true dangers presented by that specific substance can actually be identified. Extracting that code from Section 14 of the SDS, that is the single, absolutely crucial action that unlocks the true law of the land for maritime transport. And this beautifully illustrates exactly what you unlock once you have that number. Think of this as a simplified look at the Dangerous Goods List, which you'll find within the IMDG code, basically the International Rulebook for Maritime Shipping. The list is essentially a giant index arranged by UN numbers, featuring 18 columns of information for every single listed substance. Column 1, that gives you the UN number. Column 2 is your proper shipping name. But for tank container operators, columns 13 and 14, that is where the magic happens. Column 13 dictates the mandatory T codes, which are your tank design and construction instructions. And column 14 dictates the TP codes, the special tank provisions. This right here is where planners find the actual concrete rules they must follow. So here is the ultimate reality check for us. The DGL is the law. While the SDS is just a biography handed over by the shipper, the IMDG Code's dangerous goods list dictates the absolute regulatory law, and that law takes precedence in every single maritime transport scenario, no exceptions. Remember, the IMDG Code is produced by the International Maritime Organization for two huge reasons: to protect human life and to prevent marine pollution. When you are shipping by sea, ignorance of the DGL is simply not an excuse. You literally must always verify the SDS against the dangerous goods list. All right, let's bring all this theory to life with a real-world scenario straight from the field. I want you to step into the shoes of a logistics planner for a second. You've got a new client, Global Chem Ltd., and your mission is dubbed the Phenol Project. You need to move 24 metric tons of UN 2312, that's molten phenol, from Rotterdam in the Netherlands over to Shanghai in China. Your task is clear. Get this highly hazardous material there safely, compliantly, and obviously on time. Like any good planner, you kick off your mission by grabbing the SDS to gather your cargo intel. Now, notice the exact terrifying moment these two documents contradict each other. Look at what the client provided. Section 14 of the SDS advises you to use tank construction T7 and tank provision TP1. Okay, great, right? But wait, because you're a pro, you decide to cross-reference UN 2312 in the IMDG Code's dangerous goods list. And there it is. The DGL mandates tank construction T7, sure, but it requires tank provision TP3. TP3 is a super strict rule stating the tank's maximum degree of filling absolutely cannot exceed 95%. The SDS, it missed this completely. If you had just blindly trusted the paperwork, you would have already broken international maritime law. And managing these kinds of conflicting limits, that is exactly where expert planners earn their keep. By uncovering that sneaky TP3 requirement, you now have a massive mathematical balancing act on your hands. Limit A is driven by the chemical's expansion. The IMDG mandate, that TP3 rule, forces a maximum 95% filling limit to prevent thermal overpressurization, because that molten phenol is going to heat up and expand during the ocean voyage. But then, you've got limit B to worry about, the physical bridge weight limits governed by national law on the inland roads leading up to the port. So now, you have a strict chemical regulation fighting head-to-head against a physical infrastructure limit. So the crucial takeaway here is this golden, universal rule of logistics. The most restrictive limit always wins. Your final transport plan can't just satisfy the ocean voyage, right? It's got to satisfy the chemical regulations of the IMDG Code, plus the physical weight restrictions of the inland road transport at both the port of loading and the port of discharge. It's like a giant puzzle. You have to calculate a loading volume that leaves enough empty space inside the tank to satisfy that TP3 thermal expansion rule, while also ensuring the total gross mass doesn't snap a truck axle or violate local highway laws. But what happens if you get this wrong? What actually happens if you fall into the SDS trap, totally ignore the DGL, miss that TP3 provision, and overfill the tank? Well, falling into this trap can easily slap you with an immediate $15,000 cost. That's the very real, very painful price tag of a single, easily avoidable port rejection. The tank arrives at the terminal, the hazardous goods inspectors weigh it or check the fill limits against the DGL, they realize it violates IMDG regulations, and boom, they instantly reject it. And you were left footing the bill for delays, rerouting, and some really expensive emergency transloading. Honestly, though, $15,000 is getting off lightly. The true cost of complacency goes way, way beyond port rejections. Remember, an ISO tank is a highly engineered pressure vessel. If you overfill it simply because you followed a generic SDS instead of the DGL's TP3 rule, thermal expansion is going to happen, and that liquid will literally have nowhere to go. This causes severe mechanical failure. Safety valves can be compromised. Suddenly, a simple little paperwork error made in a quiet office turns into a catastrophic leak at sea or at a busy terminal. It's a potential chain reaction that could endanger a crew, shut down an entire port, and trigger a massive international incident. The entire system of dangerous goods transport is literally built to prevent that single point of failure. The invention of the ISO tank didn't eliminate risk, it just reorganized it. It shifted the responsibility from manual labor to engineering integrity and really rigorous inspection protocols. A transport plan isn't a static document, it's a living process. It has to be built on strict verification, not just blind form filling. The SDS is your first clue, but the DGL? The DGL is your law. So I'll leave you with this final thought to carry into your own operations. When the stakes are this incredibly high, what will you trust on your next shipment?